So that's it. Okay, so an object of mass is blah 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 blah, and we are to is suspended by a thread and lowered until half of its volume is immersed in a liquid of then calculate the weight of the object in the liquid. Okay. Dwells on Archimedes' principle. This question dwells on Archimedes' principle. So let me find out from Aisha. Okay, no, Theater, tell us, give us Archimedes' principle. Or what is Archimedes' principle? Can you state the principle for us? Theater, just try.
It
Mhm.
states that when a body is wholly or partially immersed in water.
In fluid, not in fluid.
Please, I can't hear.
Theater, what I'm saying, not in water, in fluid.
Okay, in fluid.
Mm-hmm.
The volume of the object is equal to the volume of the submerged part of the water.
Theater, what you are saying is true, but it
Please,
isn't
I can't
Archimedes.
hear.
Oh, really? Is it better?
Yes.
What I'm saying is that what you just said is true, but it isn't directly Archimedes' principle. This is looking like ABS principle. Okay. What you said is true, but it isn't directly Archimedes' principle. Okay. Let's hear from Aisha. Aisha, what is Archimedes' principle?
Archimedes' principle says that if a body is fully or partially immersed in a fluid, the body displaces, the body experiences an upthrust in which um, hmm,
Mhm. Okay, you started so well, but the ending is a bit problem or problematic. Okay, so let's hear from Yasmin. Yasmin, tell us what you remember about Archimedes' principle.
The Archimedes principle states that when a body is fully or partially immersed in a liquid, it experiences an upward force which is equal to the weight of the fluid displaced by the body.
Thank you. Okay, but the only part I will not agree is that it isn't only about when the body is displaced in liquid, it's fluid, and it can be gaseous or can be liquid. Okay, so when the principle says that when a body is fully or partially immersed in fluid, it experiences an upward force or upthrust, which is equal to the weight of fluid displaced by the body. So when a body is fully or partially immersed in fluid, it experiences an upthrust, upward force, which is equal to the weight of the fluid displaced by the body. A practical application of this is that you see, when you visit the pool and then you are playing with a ball, okay, as you swim, if you try to suppress the ball in the water, okay, it is difficult. But the moment you take your hand off the ball suppressed in the water, it pops up. It is always as if there is something within the fluid which tries to push up objects submerged within. So that force which pushes the ball, the submerged ball out, is what we are calling as upthrust or upward force. Now, if you try to push a stone underwater, for a stone, when you submerge it in liquid or water, and then you take your hand off, as for stone, it will not pop up. Another application, whenever you have inflated balloon, and then you take your hand off it, the balloon by itself goes up. The force which pushes it up is the upthrust. So upthrust exists in fluids, which can be liquid or gaseous. Please, is that okay? Now, in the lab, how do we measure upthrust? How do we measure upthrust in the laboratory? Let's hear from Mami. Mami, how can we determine upthrust, upward force, in the laboratory?
Please, since the upthrust is equal to the weight of the fluid displaced, we can, when we submerge object inside, we can fill a user can with water and submerge the water inside for the water displaced to flow to the spout, and then measure the weight of the water to get the upthrust.
Okay, so this is one way of determining upthrust. Can we have a different way of determining upthrust in fluids? Can we, anybody? Can we have any different way of determining upthrust? Eva, do you have any idea? Janice, any idea?
No, please.
Okay,
No,
so Mami just informed us about how to determine. The other way is that have a spring balance objects in air. So determine the weight of objects in air. Assuming this is the weight. Since the object is suspended on the spring on the balance, it will record
Mr.
the weight.
Idiot,
Hello.
please, the line is breaking.
Really?
Yes, please.
Okay, hold on, let me connect something else. Okay, I'm coming. All right, so by weighing the object like this, you have the object weight in air. So let's W air be equal to weight in air. And the weight in air of the object is the object's real weight. Okay. Now, the object is also weighed in liquid. Maybe you want to determine upthrust in air. So you submerge the object, whether fully or partially, in that desired liquid. But let's also incorporate Mami's explanation. We are also interested in the volume of liquid displaced by the object. So we do this using Eureka can. There's a spout of the Eureka can. We have this as the spout of the Eureka can. Below it, we have a beaker which will collect the displaced water. So by lowering the object in the liquid, we can determine the weight of the objects in the liquid. So, weight of objects in liquid. This is weight of objects in liquid. Okay, then this will also give us the volume of the displaced water. Okay, volume of water displaced by the same objects. Okay, now after determining this, you can determine what you realize is that the weight of the object in liquid recorded by the spring balance will be less than the original weight of the object in air. So it will be observed, the observation will be that the apparent weight, or W in liquid, which is equal to apparent weight, will be less than, or is less than, the real weight. The real weight, which is weight in air. So the difference between the apparent weight and then the real weight will give you the upthrust. So the upthrust, therefore, will be equal to weight in air minus weight in liquid. Or upthrust is equal to real weight minus apparent weight. Now, Mami also spoke about collect this water. If you weigh, if you determine the weight of this liquid displaced or water displaced and then the beaker, after determining the weight of the empty beaker, you can also find the weight of the liquid in the beaker. So you subtract weight of the empty beaker from the weight of the beaker plus the liquid to get weight of the liquid displaced. And practically, it will be seen that the weight of water displaced is equal to the upthrust. So maybe assuming the weight in air of the object is 10 Newton, then weight in liquid is also 9 Newton. It will be observed that the difference between this will give us the upthrust. So the upthrust will be equal to 10 minus 9, which is 1 Newton. Now, if the experiment is conducted so well, it will be observed that the weight of the liquid displaced when the object is lowered will be equal to 1 or close to 1 Newton. Therefore, we conclude that upthrust is equal to weight of liquid displaced by the same objects immersed in the liquid. Please, are you following? Are you following?
Yes,
Yes,
please.
Good. So, two ways of determining upthrust is that Weigh an object in air, weigh the object in liquid. The difference between weight in air and then the weight in the liquid is equal to the aptras. So we conclude that real weight minus apparent weight is equal to aptras. This same aptras, by experiment, let's represent aptras by U. U is equal to weight in air minus weight in liquid, or real weight R minus apparent weight A. This same aptras is also equal to weight of objects, weight of liquid displaced. Weight of liquid displaced can also be mass of liquid displaced, times gravity. And this is coming from weight being equal to mass times gravity. Okay. Mass is also equal to density times volume. And so we can say that aptras can also be equal to density of liquid displaced. Let me write it in words before using symbol. Density of liquid displaced times volume of liquid displaced times gravity. And so aptras is equal to rho, where rho is the density of the liquid, times volume of liquid displaced times gravity. And so aptras is directly proportional to density. Aptras is directly proportional to volume. As for gravity, it is a constant on the surface of the earth. And this is the reason why we can easily float as human beings. We can swim in water than float in air, because the density of water is far, far greater than density of air, because aptras depends on density. This is also the reason why we can easily swim and float in deeper water than shallow water, because with deeper water we can displace large volume of water. But if the water is shallow, you can only displace small, and aptras depends on volume of the liquid displaced. So we can therefore connect the two, that aptras can be weight in air minus weight in liquid, which is also equal to density of the liquid times volume of the liquid displaced times gravity. This is the foundation on which the last question depends on. So let's quickly apply this to solve our problem. All right. So let's go back and look at the question. An object of mass 80 gram and density 12 gram per. So let's put our figures. This object submerged in liquid has a mass of 80 gram. So mass of objects equals 80 gram. and has a density of object. This is also 12 grams per cm cube. It's suspended in a it's suspended by a thread and lowered until half of its volume is immersed in a liquid of density 0.8 gram per cm cube. So density of liquid is also given as 0.80 gram per cm cube. Calculate the weight of the object in the liquid. So we are looking for weight in liquid, WL, or liquid. So once we can determine the real weight, we can determine the upthrust, then we can find. So we could solve this using upthrust, which is weight in air minus weight in liquid, is equal to density, weight of fluid displaced, density of fluid, or here liquid, volume of the liquid displaced times gravity. This is upthrust, this is upthrust. Okay, now we can easily find the weight in air because we have the mass of the object, density of the object, and weight in air can be equal to mass of the object times gravity, isn't it? Hello, is that right?
Yes, please.
So help me determine the mass of the object. Mass of objects. We have, oh, okay, we even have the mass of the objects, 80 grams. Good. So the weight in air is 80 grams times, you see, usually to find weight, it is mass in kilogram times acceleration due to gravity, which is 10. Let me give you another way of doing this without converting the mass from gram to kilogram. The other way is that, you see, 1 kilogram mass would give you a weight equal to 1 times acceleration due to gravity, 10 meters per, so you know you have 10 Newton. Meaning 1 kilogram mass would weigh 10 Newton. So if I have 1 gram mass, 1 gram is equal to 0.001 kilogram, right? So if you convert the mass in gram to kilogram, then the weight will be equal to the mass in kilogram times 10 meters per second squared. This is 0.01 Newton. Now with this, I know that every 1 gram mass would weigh 0.01 Newton, just as every 1 kilogram mass would weigh 10 Newton. So if you give me mass in gram, I don't need to convert it to kilogram before multiplying by gravity. All that I do is that because I know 1 gram would weigh 0.01, if you give me x grams, x times 0.01. So this will be times 0.01 Newton. Then this is converted to weight. Please, is that understood? Is that understood?
Yes.
Okay. So you have 0.8 Newton as the weight in air. Okay. Now, so we have this 0.8 minus, this is what we are looking for. We don't know. But let's find the upthrust. Upthrust is density of the liquid, which is given to us as this 0.8 volume of the liquid displaced. Now, I just told you that when an object is fully or partially immersed in fluid, the volume of the liquid displaced is equal to the volume of the object. So if we are told half of the volume of the object is submerged in the liquid, then it means the volume of the liquid displaced will be half of the volume of the object. So let's find the volume of the object and determine half of the volume, which will be equal to the volume of the liquid displaced. Do that for me. Calculate that for me. We are given the mass of the object, 80 grams. We have the density. Let's find the volume of the object. Then we are also told that until half of its volume, until half of the volume of the object is immersed in the liquid. So let's find out half of the volume of the object, which will be equal to the volume of the liquid displaced. Janice, have you finished?
No, please.
Eva,
No, please.
Tata, this is roll call. TT finished.
Nope.
You must be true by now. Volume of that volume of the part of the object submerged in water or in the liquid. Jan is finished.
So I got the volume to be 100 centimeter cube.
Come again, come again. Dennis, come again.
100 centimeter cube.
As the volume of the, is it of the object or that part of the object submerged?
Of the object.
How did you do it?
Mass over density.
So the mass of the object, yes, volume is equal to mass over density. So 80 grams divided by density of 12. And John, you said that is 100.
Please. No, please.
Hey, Janice, your eyes are no good. Put on your glasses. So what did you get? Eva, what did you get for this calculation? Let's not waste time.
6.67.
6.67 cm cubed. So this is the whole volume of the object. Then we are told that half of this is submerged in the liquid. So volume of object submerged would be half of 6.67. TT, half of this will be equal to, half of this volume will be equal to
3.33.
3.33 cm cubed. So this is the volume of the object submerged, which is equal to the volume of the liquid submerged. So this V will be 3.33 cm cubed times 0.01 Newton. And this is, I'm just multiplying by 0.01 Newton because you see, this is mass. So once you multiply 0.8 by this, you have the mass. So the mass in gram times 0.01 Newton to convert it to weight. All right. So theater, multiply them for me. 0.8 times 3.33 times 0.01 Newton. Multiply them and then give me the feedback.
0.02664 Newton.
Is that 3?
0.02664.
0.02664 Newton. So this is the upthrust. This is equal to the upthrust on the objects immersed. Okay. So if weight in air minus weight in liquid is equal to the upthrust, then help me find the weight of the object in a liquid. Help me find weight of objects in the liquid, which is WL subscript L. And I'll demand the answer from Yasmin. You would give me this answer, meaning you must calculate well. Mami, I'll also be interested in your answer. So I'll be comparing the answers from the two of you.
Please, I got minus 0.7733.
No, minus is not true. Open your eyes. Minus is never true. Open your eyes well to do the change of subjects. Mommy, tell us.
Please, I got 0.77336.
That's correct. 0.77336 Newton.
Yes, please.
That's correct. So this is it. So this becomes the apparent weight of the object. The apparent weight. Okay, work set for you under the same concepts. And this is a question that dropped 2021. In 2021, their first physics paper was cancelled. So let me write the work set on the board for you. You do this and then send it to me. So I mark for you. And send a report to your parents. So derive an expression for the apparatus on a body of weight. Derive an expression for the apparatus on a body of weight W and density sigma. Note the symbol well. Sigma. When it is immersed in a liquid, when it is immersed in a liquid, I'll answer the first one with you so that you'll try the second one. Immersed in a liquid of density rho. Of density rho. Then the B part, this is A, B. A solid weighs 237.5 grams in air. And 12.5 grams when immersed okay, when it is immersed totally in a liquid of density 0.9 gram per cm cube. Calculate I, the density of the solid. I.
Mr. Dear,
Hello.
please, the light is reflecting on the board, so I can't see you.
Oh, I'll help you see. Don't worry. Let me take a shot of the question and even drop it in your group. So the question is sent to the group. So once it is even sent, let's start solving it. Okay, to help you to understand, okay, the concept of Archimedes principle, let's all look at it. So question 1, derive an expression for the upthrust on a body of weight W and density sigma when it is immersed in a liquid of density rho. In fact, when such a question is given to you, our expectation is that derive a relation or a formula for upthrust, which will be in terms of the variables given: weight W, density of the body sigma, and density of the liquid rho. You don't need to introduce any letter or symbol which was not given to you. The moment we see a foreign symbol which wasn't given in the question, it is wrong. So let's see how to go about such a problem. We know that upthrust equals rho Vg, where Titi, I hope you can see.
Yes, please.
Rho equals density of liquid. V equals volume of liquid displaced. G equals gravity. So now rho is given to us. These are not given to us. So we need to express these ones in terms of whatever we are given. How do we get the volume of the liquid displaced? Now, once the body is immersed in the liquid, it means that the volume of the object will be equal to the volume of the liquid displaced. I hope you are with me.
Yes, please.
So the volume of the object becomes the volume of the liquid displaced if it is immersed fully. We are not told that it is partially immersed, meaning the whole volume of the object is immersed within the liquid. So let's find the volume of the object. What we have the weight of the object. We also have the density of the object. I want you to help me find the volume of the object. Volume of the body. If we have its weight W and then its density sigma, start work. Use what this information given to us to find the volume of the object or the body? $2 minutes. I'll come back to you in 2 minutes time. So quickly think through and then get it for me. We are looking for volume when we have weight of the object and the density. Aisha, are you there? Oh, Aisha is gone. Janice, are you true?
No, please.
Hurry up. No, please, way. Eva,
No, please.
no, please, way. Mommy,
Yes, indeed, yeah.
are you true? You are not sure.
Yes.
Uh-huh. Yeah,
Yes, sir.
how far? Very, very far, right?
No, please.
Are you true?
Something like that.
Okay, let's see what you had. Cheta, what did you get for volume of the body in terms of what and what was given? Cheta, I'm listening. Hey, Cheta, are you there?
Yes, please.
And let me have your whatever you had.
I tried this in the weight.
So weight, because weight is equal to mass times gravity.
Then
Give me what you had for volume finally. Because if it's not correct, I'll solve it with you. So what did you get for volume finally?
nothing.
Hey, really? Uh,
Yes.
okay, then it's really nothing. Please, if any of you had something, let me know. Share it with us. Did you get something for the volume before I solve it with the house? Mommy, what did you get?
Please, what about weight out of gravity times density?
Come again.
Weight out of the gravity times density.
Time density of the body, right?
The density is also dividing the weight.
Okay, so let's see. So whatever you had, you mark yourself. So I have weight of the body. I have its density, and I'm looking for volume. So weight is equal to mass times gravity. Mass is density times volume. So density of the body times the volume of the body multiplied by gravity would give me the weight W given. Now I'm looking for the volume, so I make V the subject from this. W over density times G. Mommy, is that what you had?
Yes, please.
Yeah, then you can be smiling to the bank. It's correct. So this expression gives me the volume of the body or the object. Okay, therefore, upthrust will be equal to density of the liquid row times the volume of liquid displaced. Don't forget, I said volume of liquid displaced becomes the volume of the objects when submerged. Okay, so the volume of liquid displaced here will be equal to W over density of the body times gravity, and then G would cancel out. Therefore, the upthrust will be equal to density of the liquid times the weight of the liquid divided by density of the body. This will be the expression for upthrust. And the good thing is that we have this in terms of whatever we're given. We're given rho as the density of the liquid, W as the weight of the body, sigma as the density of the body. Please, any question? Any question, or you are all fine? Okay, then let's move on to the second question. Do I clean it?
No, please. No,
right.
please.
Okay, hurry up. After I'm recording, so you can have the video after the class. Please let me know when you finish. Do we continue? Hello, class. Do we continue if you are finished?
Yes, please.
All right. So the next question: a solid weighs 237 grams in air and 12.5 grams in 12.5 grams when it is immersed totally in a liquid of density this. So we have the weight in air, weight in liquid. The density of the liquid is this. Calculate the density of the solid. So weight in air minus weight in liquid equals upthrust. And upthrust is equal to density of the liquid, volume of the liquid displaced times gravity. Okay. Now weight, you see, weight in, these weights are in mass. We can decide to express them as mass. Don't forget, weight in air will be mass in air times gravity minus mass in liquid times gravity, which is equal to the weight of the liquid displaced, which is the upthrust, rho mass of the liquid displaced times gravity. And this is what we have expressed as rho v. Don't forget. So it means that G can cancel out gravity. So we have mass in air minus mass in liquid is equal to mass of the liquid displaced. And mass in air is 237.5 minus mass in the liquid is 12.5. This is equal to mass of the liquid displaced equal to the density of the liquid, which is 0.9 times volume of the liquid displaced, which we don't know. Please, are you okay? Are you okay? So with what we've done so far? Give me feedback. Are you okay?
Yes, please.
Okay. So let's subtract 12.5 from 237.5. And then give me the final answer. Eva, do that for me. 237.5 minus 12.5. Is it 225?
Yes, please. 225.
So let's find the volume of the liquid displaced. 0.9. 0.9. And this is 225 divided by 0.9.
250.
250.
So 250 centimeter cube is the volume of the liquid displaced, which is also equal to what? Which is also equal to what? Janice and I'm listening, which is also equal to what?
Yeah, can I get chicken?
The volume of the oil.
Yes.
Please pay attention and then stop. Jasmine, mute.
Yeah.
Jasmine, mute yourself. So volume of liquid displaced is 250 cm cube. And this is also equal to the volume of the solid. Now, if you are told that the solid weighs 237.5 in air and its volume is this, its volume is 250, can't we find the density of the solid? So go ahead and then calculate the density of the solid for me. Yes, what have we had for the density of the solid? What have we had for the density of the solid?
.95.
0.95. Okay, so rho of solid must be equal to mass of solid over volume of solid. So the mass of the solid is 237.5. Its mass in air, 237.5 divided by 250. And Johnny said you had what? 0. What?
95.
Density. So gram per cm cube. So that's it. It's not a difficult question. Now, this same question, somebody can also decide to do it this way. Since it's about weight in air, weight in liquid, we can also decide to express whatever we are given in terms of weight. And that is, if 237.5 gram mass can be expressed in weight as 237.5 times 0.01 Newton minus 12.5 gram expressed in weight, 12.5 times 0.01. Okay, which is equal to, we change, once we are not expressing everything there, the masses into weight, then we change the density of the liquid, which is given to us in gram per cm cube to kilogram per cm cube, and 0.9 will be 900 times the volume of liquid displaced, we don't know. This time, then we multiply by gravity, which is 10. Okay, now when we do that, we will have the volume of the liquid displaced in meter cube. So instead of this, it will be expressed in meter cube. That's the only difference. Okay, so there are several ways to go about the problem. Now, the next question is that calculate the fraction of the solid submerged in a liquid of density 1.19 gram per cm cube. Calculate the fraction of the solid submerged. Fraction. Eva, are you there? Eva.
Yes, please.
Can you explain what they mean by this question? How you understand the question? Calculate the fraction of the solid submerged in a liquid of density 1.19. How do you understand the question? Just a quick view of yours. If I'm waiting for you. Hey, Eva. Okay, mommy. Mommy. Mommy.
Mr. Yeah.
How do you understand the question? Yes. Your
Yes.
calculate the fraction of the
The
solid.
line is breaking.
Mommy, I'm
Please,
listening.
think is saying that
Mhm.
maybe we should find the part of the volume of the solid that's inside the water.
Good. It meaning that can we then say that the solid is fully submerged in the liquid?
No, please.
Because it's about fraction, and fraction is about parts out of total. Okay. What the question therefore means is that the body floats. We have part of it submerged in a liquid and part of it under. Okay. The only difference now is that the density of the liquid is changed. Before, the density of the liquid was 0.9. But this time we are told that calculate the fraction of the solid submerged in a liquid of density 1.19. So we've just changed the liquid, but it floats. If it floats, then we apply the principle of flotation, that mass of solid must be equal to mass of liquid displaced. Okay. Mass of the solid. Mass of the solid is density of solid times volume of solid. So density of solid times volume of solid, which is equal to mass of liquid displaced. Density of liquid times volume of liquid. The density of the solid, we've determined it. And Janice, what did we get for the density of the solid?
0.95.
Good. So we know it is the same solid as the first situation we considered. So 0.95 volume of the solid, we have even determined it. We can find it once we have the density and then its mass, we can find the volume, but we are maintaining it for a reason. Now the density of the new liquid, we are told, is 1.19 times volume of the liquid displaced. Now this question talks about fraction. Calculate the fraction of the solid submerged in a liquid of density. So I want to have a ratio of this over this. Volume of liquid over volume of solid. Volume of liquid displaced over volume, the whole volume of the solid, would be equal to 0.95 over 1.19. Please divide for me. 0.95 divided by 1.19.
0.798.
0.798. Let's express this as a percentage. So times 100%, this is equal to 79, approximately 80%. Approximately 80%. What I have is the fraction of the solid submerged in the liquid. The fraction of the solid submerged in the liquid is 80%. Now, I'm sure you are confused. Why this calculation, right?
Yes, please.
Good.
Yes,
Now,
please.
if we find volume of liquid displaced, what have we found? If we find volume of liquid displaced, what is it? This is equal to what? Oh, give me your views. If you determine volume of liquid displaced, this is equal to what?
Volume of the object.
Come again.
Volume of the object.
No. No. Oh, more views. We are learning. So just feel free to share your views with me. Oh, Yasmin, Mame, Eva, speak. If we find volume of the liquid displaced, this is equal to what?
The fraction times the volume of the object.
So, you see, the volume of the liquid displaced is always equal to the volume of that part of the object in the liquid. Earlier, I told you that when the object is fully submerged, the volume of the liquid displaced is equal to the volume of the object. If it is halfway submerged, the volume of the liquid displaced is equal to half of the volume of the object. Are you okay? Class, are you okay?
Yes, please.
So, if you find a ratio of volume of the liquid displaced over volume of the whole solid, it means this is the volume of that part of the solid in the water, submerged in the water, divided by the whole volume of the solid. So a fraction of VL, the ratio of VL on VS gives us is equal to fraction submerged, fraction of solid submerged. Submerged. Meaning VL is the part under the water, VS is the entire volume of the solid. And that is exactly what the question asks. Calculate the fraction of the solid submerged in a liquid. Fraction, part out of total. Okay, so by calculation, this fraction, when is equal to approximately 80%, it means that we have 80% of the solid submerged in the liquid and only 20% above the liquid. Please, do you understand? Hello, do you understand?
No, please.
Yes, please.
Yes, please.
I'm going over. So those of you who are not clear, the question asks that we are to find the fraction of the solid submerged, okay, in a liquid of density 1.19. Once we are looking at fraction, it means we are part of the solid up and part down. So this fraction will be the volume down submerged in the liquid divided by the whole volume of the solid. So, but because it's about fraction submerged, it means the solid floats. So we apply the principle of flotation. Mass of solid equal to mass of liquid displaced. This is the principle of flotation. Mass of solid equals density of solid times volume of solid. This is also equal to density of liquid times volume of liquid displaced. We have earlier determined density of the solid, which is 0.95. Our first question we solved. Volume of solid we can calculate, but we are looking for fraction. So we maintain this and then take the ratio. And this is equal to the density of the liquid is changed, meaning that the same solid is taken into a different liquid. And we are to determine how far part of it will be submerged. So 1.19 times the volume of liquid displaced. Okay, now since VL is equal to volume of solid submerged, create a ratio of VL over VS. And that's exactly what we've done. So we are making VL over VS the subject, which gave us 0.95 divided by 1.19. So this is density of solid divided by density of liquid. Okay, what does this ratio mean? It means that since volume of liquid is equal to, since volume of liquid display is equal to volume of that part of the solid under the water divided by VS, the whole volume of the solid. So this ratio is equal to fraction of solid submerged. Fraction is fraction. Fraction is, okay, fraction is the whole fraction we know, but you see, fraction can also be expressed as a percentage. 50% is equal to half. 70% is equal to 75% is equal to I think 3/4. Okay, 25 is quarter, 1 out of 4. So I'm just expressing the fraction in percentage. So VL over VS is approximately equal to 80%. You see, this is how we can always calculate the fraction of iceberg. You know, whenever you drop ice in water, greater percentage of it is under the water. Okay, submerges. Hence the old or the good old saying that what you see is just the tip of the iceberg. Meaning, if you see an iceberg, a greater percentage is under the sea. How when ice floats, almost more than 80% of the volume is always hidden. And how do we calculate it? We calculate it using the same concept. Volume of liquid divided by volume of solid. Okay, it's equal to, oh shit. Okay, so volume of liquid divided by volume of solid is equal to density of solid divided by density of liquid. Now the density of ice, which is in a solid state, is approximately about 0.95 gram per cm cube. And the density of water in a liquid state is approximately 1. So for an iceberg, the percentage fraction, okay, percentage fraction is always about 95%, meaning whenever you drop ice on water, about 95% of the volume of ice is hidden in the water. What you see is just about 5%. So this is the concept applied in determining fraction submerged. Please, I hope you're okay. Are you okay?
Yes, please.
Please note this question at your free time. Go over and then master how to solve this question, and it will help you in a lot of calculation. I'll just leave you with the last question. The last question says that calculate the density of a liquid in which the solid would float. Calculate the density of a solid in which the solid, sorry, let me go over. Calculate the density of a liquid. This time we don't know the liquid's density. In which the solid would float, this same solid would float with 1/5 of its volume. 1/5 of its volume exposed above the liquid surface. Whoever gets this question correct will be awarded. I will send you airtime. So take note. Calculate the density of a liquid, meaning the density of the liquid is not known, in which the solid would float. There's flotation, so you apply the principle of flotation with 1/5 of its volume exposed, meaning 1/5 of the volume is above the water, and if 1/5 is exposed, then you must know the fraction which is submerged above the liquid. So the third question is your assignment, which I will be expecting from you by Saturday. So the deadline for the submission of the third question, I, is on Saturday. Please, girls, sit down, make time to look at it, do it, and then forward it to me for marking. Is that okay? Is that okay?
Yes,
So
please.
use
Yes,
the
please.
idea from I, and I think you can easily get it. Whoever gets it right will be awarded. This is where I draw the curtains on today's meeting. Thanks for your time and everything. Please spend time to go over whatever we've done for the day. We'll have another wonderful session, next Tuesday. Good night to all of you.
Good night, Mr. Adira.